So many things within vMix to sort out. Unbelievable. All right. Mamma mia. Good evening, everyone. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South. The time is now 10:01, and welcome to tonight's session. Enough of that. All right, the Astronomical Society of Victoria is founded in 1922, comprises well over 1,600 members throughout Victoria and other states of Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science, and to provide greater facilities of the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, the latter being held on a Saturday night. Meetings start at 8 p.m. at the Mullier Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and the surrounding streets. Admission is free and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at the Melbourne Observatory. Receipt of the ASV magazine Crux, containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and the 300mm portable reflector. There's a 200mm refractor managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible apparently to members too. The Society also has a number of 200mm refractors available for short period loan, so members can try before they buy. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. Where am I? Instrument making is only one of the... No, I skipped a sentence because I took my eyes off the ball. There are a range of instruments available for members to use, the larger two only with appropriate training, which range from 300mm to 1000mm in size. Also located on the site is a fully steerable 8.5 metre steerable radio telescope, which members can access with involvement with the radio astronomy section. Good evening to any radio astronomers listening tonight. Members are also encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same thing. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors are provided in the yearbook. However, if you don't have the yearbook, because you have to be a member to get the yearbook, this is the last page of the yearbook that I've ripped out so I can read this. Yes, you can go to the ASV website at www.asv.org.au and all will be revealed. Please note that the ASV will conform to all government health directives. ASV events may be required to be challenged, as in cancelled, moved or postponed. The Secretary, you can write a letter to the Society if you wish. The Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001 is the snail mail, which is going up in price to send a mail. Oh, thank you. So there it is, and well, that's it for tonight. So we'll see you all next Friday. The YouTube stream is running. It's good to see. It's I think the internet in the last 48 hours has stabilised. So if you wish to view in relatively high HD, the YouTube stream is working, but however, there's about a 20-second delay between what I'm saying right now on 80 metres and through the Melbourne TV repeater. to what else is happening. So we're on broadcast frequency 3541 kilohertz, getting it all mixed up tonight. Our prime frequency 3541 kilohertz, and streaming on YouTube and also via the wonderful television repeater VK3 RTV Digital Channel 1. Good evening to all viewers. Coming up to that. We also have Discord, so if you wish to watch the proceedings on Discord as well, there is a vision available via Discord. Just install Discord and search for, I think it's astronomy. What's the link to our astronomy thing? Video cast of ASV? I don't know, it's something, but just look for ASV radio on Discord and you should find it pretty quickly. Discord, I don't know. Anyway, g'day to Martin, VK7JAH. Richard, VK3VRS, and that's all that's there at the moment. And we do have a email address if you wish to. What, on Discord?
Yeah, they're watching the stream.
Oh, okay. I haven't made any comments yet. G'day, Steve, VK3SPX. He's just chimed in. G'day to Mike, Mr. XL. Hello, Michael, our local amateur. Very local. Where's my mouse gone? Oh, there it is. And also email address, I was saying. We're also tuned. There is an email address, vk3ekh@gmail.com. And I can see that Don and the VCL Factor has chimed in there. G'day, Wayne. And all very good. No worries at all. Thank you guys for reporting there on the email side of things. Excellent stuff. Now, I've got a full-on night tonight, so this could go to about 12 o'clock. No, it won't. It won't do that. But I do have a couple of things, recordings. A podcast recording from Astrophiz, another one. But tonight's a little bit shorter in length, and it's to do with Professor Matthew Bales, who recently got the Shaw Prize this week, in fact. So I'm about to go into all that in a minute. So, all right. Now, time. I've got to just be careful of time here because we do have some sky notes to present tonight, being the 1st or the 2nd of June, but the beginning of a new month. And sky notes. Okay, just have a quick look at them, see how long they will take. Actually, there's not much there to be honest, so I might be able to scoot right through the sky notes without using up too much time tonight. Not that it's really a problem, to be honest. Okay, sky notes presented by Tanya Hill, Dr. Tanya Hill of the Science Museum Planetarium. Every month she prepares the sky notes and sends them out, or puts them up onto the internet. So she's saying tonight. Do I mention that? No, I'll just go straight into the winter solstice. It is winter solstice this month. Thank God for that, because I'm getting really tired of the dark mornings. Anyway, it is winter solstice this month in the southern hemisphere on the 22nd. The sun rises and sets at the most northerly points on the horizon. Its path across the sky is lowest and shortest, giving us our shortest day of the year. The sun's rays reach the ground at their shallowest angle, hence the longest shadows, and provide the least solar energy per square metre. Solstice comes from the Latin sol, sun, and sistere, which means to stand still. At the solstice, the sun stands still at its northernmost point, after which its path shifts southwards, leading to the spring equinox. Solstices and equinoxes result from the Earth's rotational axis being tilted at an angle of 23.5 degrees from its orbit around the sun. Okay, so if we look at sunrise and sunset times for this month of June, on Tuesday the 1st, the sun rose at 7:26 a.m., setting at 5:09, with the average day length of 9 hours and 43 minutes. On Sunday the 11th of June, the sun will rise at 7:31 a.m., setting at 5:07. On Wednesday the 21st, the sun will rise at 7:36, setting at 5:08. And by the end of the month, on Friday the 30th, the sun will rise at 7:36 a.m., setting at 5:11 p.m, with a day length of 9 hours and 34 minutes. The moon phases. There's a full moon on Sunday, the 4th of June. There will be a third quarter on the 11th, Sunday the 11th. And then there's a new moon on Sunday the 18th, and back to a first quarter on Monday the 26th. Moon distances. The moon will be closest to the Earth, perigee, on Wednesday the 7th at a distance of 364,861 kilometres. Then on Friday the 23rd, it'll be furthest from the Earth, apogee, at 405,385 kilometres. So now let's quickly get into the planets for the month. Mercury rises in the east from 5:30 a.m. early in the month, and by 6 a.m. mid-month. It is moving closer to the sun, and by late June it will no longer be visible. So I've always said that there are a number of times throughout the year that Mercury can be seen from Earth without the sun blinding you. This is one of them. Venus, as the evening star, continues to be visible from 5:30 p.m. in the west before setting around 8:30 p.m. It has reached its greatest elongation or angular distance from the sun and will now be seen progressively lower each evening. Mars, the red planet, remains in the northwest from 5:50 p.m. before setting around 9 p.m. this month. It is currently 295 million kilometres from Earth, but not as bright compared to when closest to the Earth at 54.6 million kilometres, which occurs every 2 years. Jupiter is a bright early morning planet this month, rising in the east from 4 a.m. early in the month and by 3 a.m. later in the month, before fading in the dawn light before sunrise. Saturn, with its yellowish tinge, rises around midnight early in the month, and earlier each night before reaching its highest elevation in the north at 5:30 a.m, after which the ringed planet is lost before dawn. Meteors. There are minor meteor showers this month centered in Scorpius and Sagittarius, and the Boötids, B-O-O-T-I-D-S, Boötids can also appear from very late in June into early July. Although low in numbers, less than 10 an hour, they can often be spectacular, with many displaying a yellow-orange colour. The best time to see meteors is after midnight, with no moon in the night sky. The other shower this month is the Arietid, A-R-I-E-T-I-D, the Arietid meteor shower in the constellation of Aries, of course, and it occurs through to June 24, but peaks on June 11. So from Melbourne, the shower is likely best seen just before dawn, and they don't give you an average hourly rate there for meteors, but nevertheless, June 24. June 11 are peaks, and but it is an active meteor shower for the majority of the month. Arietid meteor shower. Anyway, look towards the constellation of Aries. So, stars and constellations. Orion has disappeared below western horizon, but his two dogs, Canis Major and the star Sirius, low in the west, and Canis Minor with the star Procyon, low in the northwest, are still both in our skies. In the north, Leo the Lion is still visible in the northwest with the bright star Regulus. Look for a large hook of stars or inverted question mark to locate this curving mane and shoulders. Looking towards the east, Scorpius is in the southeast this month with a red giant star Antares as the middle of 3 stars that form the Scorpion body. During winter, the Centaur Archer Sagittarius suits below the Scorpion, which is its bow and arrow, the famous teapot asterism. Oh, I've got an image for that. Let me see where I can bring that up. There it is. There's the famous Scorpion and Sagittarius constellations on the screen as I speak, and Sagittarius and Scorpius with Antares in the east. You can use Stellarium, which is a free program. It's a star program, very accurate and very good to use. A Stellarium, what you're seeing on the screen is a view out of Stellarium at about 8 p.m. on the 10th of June, where Scorpius and Sagittarius will be in the sky looking due east. In the south, high in the southeast is Crux, the Southern Cross, with the pointers Alpha and Beta Centauri lower down. In the darker skies, the 2 neighbouring galaxies, the large and small clouds of Magellan, can be seen as small, isolated patches in the southeast. From our southern latitude, they are easily seen every night. From less polluted skies, the Milky Way's broad band of billions of stars and numerous interstellar dust clouds stretches across the sky from horizon to horizon. Some foreground stars in our local region of the galaxy can be seen, but the dust clouds obscure our view further into the galaxy. However, infrared telescopes can reveal much that is hidden to our eyes, and optical telescopes that utilize only the visible part of the spectrum. The International Space Station orbits every 90 minutes at an average distance of 400 kilometres, appearing like a bright star moving across the sky. And here are some of the brightest passes expected this month over Melbourne. On Monday, the 5th of June, at 6:40 a.m. to 6:46 a.m., coming in from the southwest to the east-northeast. Also, in the morning of Thursday, the 8th, the pass starts at 5:53 a.m. to 5:57 a.m., coming in from the west to northeast. Then in the evening, Sunday the 19th of June, there's a passing at 6:22 p.m. to 6:27 p.m, coming in from the west-northwest to the southeast. And then Monday the 20th of June, there's a passing at 5:33 p.m. to 5:40 p.m. northwest to southeast direction. They're the brightest ones. But if you go to heavensabove.com, they will give you predictions of the International Space Station as often as it will appear in our skies, and also many other objects, celestial objects, including satellites of all sorts, you're able to see through the heavensabove.com website. Be sure to register on Heavens Above so that your location information is accurate to the positional information is accurate to your location. Latitude and longitude is what I'm saying. So now it's 20 past the hour. There's a whole bunch of dates here, but I'm not going to go through them because I just haven't got the time right now. So what I'll do, I'll present those dates a little later, maybe next week. Lots of interesting things that have happened in June. Anyway, all right, you're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. Okay, now we're going to go into a half hour of Matthew Bales, and let me see how am I going to set this up right now. There's a 5-minute audio recording, courtesy of ABC VK. of 3RN. They did a quick interview with Matthew Bales the other day. I'm just going to see if I can tee this up nice and easily. And it should play if I do this. So courtesy of the ABC, 3RN. We shall go across to this recording, and this will give you a bit of a picture of what's just recently happened as far as this award prize being issued to Matthew. So let's see how we go with this.
Hong Kong Australian astronomer Professor Matthew Bales was named a joint winner of the prestigious Shaw Prize, often considered a precursor to the Nobel Prize. He received the award for the discovery of fast radio bursts, intense bursts of energy from beyond the Milky Way. Professor Matthew Bales, director of the ARC Centre of Excellence in Gravitational Wave Discovery. Welcome to RM Breakfast and congratulations.
Yeah, thanks very much. It was a complete shock.
How did you find out?
Well, I had a sort of a Google chat message from one of my former students, Duncan Lorimer, and he'd said, "We just won the Shaw Prize, 5 exclamation marks." And I said, "Who's we?" And he said, "Check your email." And I checked my email, and there was nothing there. So I checked spam, and there was something about $400,000 and click here, and you've won, and so it all just went to spam.
Did you think it was a scam?
Oh, look, I didn't know a huge amount about the Shaw Prize. I knew there was one a year for astronomy, and that some of my colleagues had won it, including Brian Schmidt, our kind of Nobel laureate. I had never really considered nominating for it or anything like that. And so I had to read up on how you actually got nominated, and it has to be confidential, so you're not allowed to know you've been nominated. And so it was just a fantastic outcome.
Can you explain for listeners this morning the work that you are being recognised for?
Yeah, we discovered a new type of phenomenon in the universe, which is a sort of an explosion that manifests itself in the radio. And those radio waves travel literally halfway across the universe and then hit the Earth. And the time delay between the high-frequency radio waves, you could think of it as 774 as opposed to 673, arrive first, and the time delay tells you how far away they are. And we discovered that you could effectively weigh the universe by detecting these things.
When you first discovered them, what was that like? Did you sense the enormity of this discovery?
I did. I went to bed, and a little bit like last night, I struggled to sleep. I just kept thinking about all the ramifications if what we'd discovered was true. But it actually took 6 years to convince ourselves that we had discovered these things, because the second one was only found again at the Parkes telescope half a dozen years later.
And what was it like trying to convince the broader scientific community of your discovery, let alone yourselves?
Oh, look, the evidence, if you just looked at the graphs, looked incontrovertible, but we knew that radio frequency interference is a growing threat to radio astronomy. And so some people said, how do you know it's not lightning or something? And then we had this great problem that microwave ovens actually give off a very similar radio signature, in fact, remarkably similar. And it was just a growing increase in technology and methodologies that meant we could separate the kind of microwaves from the real sources. And now there's several thousand fast radio bursts that have been discovered.
And how has this changed our understanding of the world, the universe, rather?
Yeah, I think there's two things. One is that there are ways in the universe to generate these amazingly intense bursts of radio waves, and that hadn't been appreciated before. And because they're about 1 trillion times brighter than anything we'd seen in our galaxy up until that point, we hadn't dared dream that such things would exist. And then if you can localize them to which kind of galaxy in the universe they're coming from, you can effectively put the universe on the scales and count the number of electrons in the universe. So it's a very model-independent way of weighing the universe.
And what does this recognition do for your work? Does it impact what you're able to do next?
Yeah, I'm fortunate to lead a large bunch of scientists in Australia in a Australian Research Council Centre of Excellence, bit of a mouthful, called OSGRAV, and it'll make us easier to get recognition for the work we're doing and give us a platform on which to promote a lot of the excellent science that's happening in Australia.
How did you celebrate?
Well, my wife has COVID, so she's kind of isolating. So I ended up like tweeting to my friends overseas, and poor old Marion was sort of coughing in the background.
Oh, I'm sorry that it wasn't more celebratory, but I hope you get the opportunity to enjoy it more in the weeks ahead. Professor Matthew Bailes, thank you very much, and congratulations.
Thanks very much.
That's the winner of the Shaw Prize in Astronomy, Professor Matthew Bailes.
ABC Listen, podcasts, radio, news.
One, two, three, four, five. Okay, we're back online here. All right. So, just bring up the level a bit. 1, 2, 1, 2. All right. So, thanks to VK, 3RM for courtesy of that little bit of audio for Matthew Bailes winning the Shaw Prize. And I've got a picture of the medal here in question. Okay, here it is. There it is on the screen right now. This is this is what's presented. The Shaw Prize, and let's see. The Shaw Prize is an annual award presented by the Shaw Prize Foundation, established in 2002 in Hong Kong, and it honours individuals who are currently active in their respective fields and who have recently achieved distinguished and significant advances, who have made outstanding contributions in academic and scientific research or applications, or who in other domains have achieved excellence. The award is dedicated to furthering societal progress, enhancing quality of life, and enriching humanity's spiritual civilization. The prize has been described as the Nobel of the East, and it was founded by Hong Kong entertainment mogul and philanthropist Run Shaw, hence the Shaw Prize. So there it is. Professor Matthew Bailes has been named a joint winner of the prestigious Shaw Prize, and often considered as a precursor to the Nobel Prize. So there it is. He received the award for the discovery of fast radio bursts, which are intense bursts of energy from beyond the Milky Way. All right, so now let's segue into the Astrophys recording. This is Astrophys episode 56. Professor Matthew Bailes magnetars supercomputers and gravitational waves. And let's see how we can go with this. If I bring up the recording, which should be just here somewhere. There it is, and that's all queued up and ready to go. And all we have to do is do this. So you're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with a regular Friday night broadcast. Here is a podcast recording with Brendan O'Brien and Professor Matthew Bales.
He's director of the ARC, the ARC Centre of Excellence for Gravitational Wave Discovery, OSGRAV. He's an advisor to the Breakthrough Listen project, as well as leading the MearTime project. His team also developed a supercomputer for the 50-year-old Molonglo telescope to transform it into a pulsar timing and FRB discovery machine. We should note here that Dr. Bales and Duncan Lorimer were the discoverers of FRB's fast radio bursts, which we have featured in a few previous episodes. He has a huge number of papers published with 16,000 professional citations in astrophysics journals. Most recently, he's co-author of a paper about some puzzling discoveries about a reawakening magnetar using instruments such as the new SKA precursor Meerkat telescopes in South Africa, the iconic Parkes dish in Australia, and the Chandra and Swift space-based instruments. We'll get to that a bit later, but first, Matthew, can you tell us about growing up in South Australia, please, and tell us how you became interested in science and space in the first place, and did you have dark skies there in your backyard in Adelaide?
Yeah, I grew up in the eastern suburbs of Adelaide. At the time, the skies weren't particularly dark, but Adelaide doesn't get a lot of cloud, so we're certainly familiar with looking up and seeing the night sky. I didn't really ever want to be an astronomer, nor an amateur astronomer. I really had a passion for understanding how the universe worked.
Yep.
And although I found the concept of black holes and things like neutron stars intriguing, I was really more interested in learning about the scientific method and how we knew about how things in the universe worked and moved and were born, etc.
Okay, how we know what we know. So, Matthew, after high school, you went on to do your BSc honours at the University of Adelaide. What was your focus at that stage?
Yeah, so I started off at high school doing engineering. None of my parents had been to university, so we were fairly ignorant of how one became a scientist.
Yep.
And my father thought it would be good for me to have a profession, so I started off doing electrical engineering at the University of Adelaide, but I really enjoyed physics subjects, and I had one particular lecturer who had a very sort of poetic style, and I found his explanations of how the universe worked and so on very interesting. And I ended up switching from an engineering degree to a science degree, and I wanted to work in relativity, and so I started studying relativity the only way you can, and that is by using the stars.
Yep. Okay, and after that, you headed up to the Australian National University in Canberra to do your doctorate on the origin of pulsar velocities. Tell us how you developed that interest in pulsars, and you might want to give our audience a reminder of what a pulsar is.
Sure. So pulsars are neutron stars. They have like a lighthouse beam of radiation. We can't see the beam in many wavelengths, but we can see it very well in the radio, occasionally in X-rays, and sometimes in gamma rays. These neutron stars are about 500,000 times heavier than the Earth, but they're only 20 kilometers in diameter.
Yep.
The fastest one rotates over 700 times a second, and the slowest one is about once every 20 seconds.
Ooh.
So these neutron stars span a vast array of parameters, In my honours year, I was studying a very special neutron star that was orbiting another one. And they were travelling around each other around about 300 kilometres per second. And these stars were very good for testing the general theory of relativity. And in fact, the discoverers went on to win the Nobel Prize for physics for the discovery of what was called the binary pulsar.
Yep.
Because the binary pulsar's orbit was shrinking by 3 millimetres per 8 hours, and they actually managed to measure that, and that was precisely the rate at which general relativity predicted the orbit should shrink if they were giving off gravitational waves.
Cool.
So really it was the study of general relativity that led me to pulsars, and then when I got to ANU I met a guy called Dick Manchester at the CSIRO, and he was one of the sort of leading pulsar experts in the world, and I did a joint PhD between CSIRO and Mount Stromlo Observatory at ANU.
Fantastic. And then you headed off to work with NASA, then Manchester, where the famous Jodrell Bank is located, then back to Australia with the CSIRO, then Melbourne University, and then to a very young Swinburne University, where you founded the now world-renowned Centre for Astrophysics and Supercomputing. That must have been an exhilarating experience to watch Swinburne graduates and researchers become astrophysics leaders all over the world now. And you're back there as a director now, or did you never leave?
In your introduction, you said I was the founder and director of the Centre for Astrophysics and Supercomputing. That's true, but I stepped down from that position in 2010 and became a Pro Vice Chancellor, and then I'm now the director of the National ARC Centre of Excellence for Gravitational Wave Discovery, which is still a part of the Centre for Astrophysics and Supercomputing, but a national one.
Fabulous. Now, let's move on then, Matthew, to your recent magnetar research. You worked with a large team using a great array of instruments to look at a strangely behaving magnetar. How was this team assembled? What instruments were used? And how was the research organised? And what did you discover? And where does that lead us next? A new theoretical model for magnetars? Oh, and you might want to briefly explain what a magnetar is, please, Matthew.
Yeah, so a magnetar is an extremely magnetic neutron star. So we measure magnetic fields in astronomy in a unit called Gauss.
Yep.
A fridge magnet would be about, 100 Gauss. And when you have a magnet that strong, although it's attracted to iron and so on, you don't notice too many fancy things about it if you grab one and twist it around.
Yep.
Turns out if you make a magnet spin, it doesn't actually like it. And it exerts a torque protesting about that spin. It actually gives off something called magnetic dipole radiation, but it's so weak with sort of the magnets that we're used to that we don't notice it.
Yep.
Magnetars are around about 10 to the 14 Gauss. That's one with 14 zeros after it.
Yep.
And they're very magnetic objects, and the magnetic field seems almost a little bit unstable. So the neutron stars I'm used to studying have magnetic fields of like 10 to the 12 Gauss, maybe a little bit less than that. The millisecond pulsars are only about 10 to the 8 or 10 to the 9 Gauss. So these things are maybe 1,000,000 times more magnetic than what we call a millisecond pulsar.
Yep.
And that seems to give them very different rotational properties to the normal pulsars we see. So one of the things about these magnetars is that they actually change their effective torque by very large factors in a very short space of time. And it makes their rotational history very difficult to track. The other thing they do is that they sometimes just completely disappear on us and we can't see them at all.
Yep.
And so these magnetars have these reawakenings or rebirths. And when they do, we get very excited because you only have a limited window in which to observe these systems before they fade away. It's usually a year or few. Like most new objects that we've only just discovered. There seems to be different classes, and there seems to be some pulsars that become magnetars and then stop again.
That's so cool. Now, recently you were also involved with the discovery of a century, that is, the momentous discovery of gravitational waves. Can you tell us a little about that, please, and tell us about your work with OzGrav and where that research project has led you and your colleagues so far?
Yeah, so OzGrav is a national kind of coalition of 6 universities across Australia. Swinburne's one of those. And many people in Australia are members of what's called the LIGO Scientific Collaboration.
Yep.
There's about 1,000 people around the world that have come together to try and discover gravitational waves.
Yep.
That, of course, happened on the 14th of September 2015. The LIGO Scientific Collaboration uses 2 gravitational wave detectors in the US, one on the east and one on the west coast of the USA.
Yep. And
these detectors look for tremors in the space-time continuum. So if a gravitational wave passes through a detector, it causes the arms to get shrunk and stretched, and using quantum optics we can actually detect these deviations in otherwise normal sort of space-time continuum.
Yep.
And if they're correlated between the 2 antennas, then you become more confident that they're real. If they're very, very strongly correlated, you can effectively prove that a gravitational wave has passed through the detector.
Yep.
This first happened back in 2015. It was published in 2016. And luckily for us, it was published just a few months before the ARC was deciding what the next centres of excellence would be. So I was the nominated director for that centre. Certainly wasn't involved in the discovery of the first black holes, but now our university is part of the LIGO Scientific Collaboration. And when the first neutron stars that were merged were discovered by LIGO, we were ready to point our telescopes in the sky to try and catch the cosmic fireworks display that followed.
Excellent. Now, a couple of episodes ago, we spoke with Manisha Caleb about her work with the Molonglo synthesis telescope. Can you tell us about that instrument and the upgrade you gave it and its new capabilities?
So the Molonglo telescope is actually the largest radio telescope in the Southern Hemisphere at the moment. It's 36,000 square metres of collecting area, but it's got, in some parts, 1960s technology and in other parts 1980s technology. So it's made up of 2 orthogonal arms. They're at right angles to each other. Yep. They're both about a mile long. That's 1,550 metres or so, and about 11 metres wide. And these 2 sort of large parabolic troughs can point at the sky with a beam that's a few degrees wide.
Yep.
And up until say 2015 or so, there was no capability to do high time resolution work at the telescope. So our group partnered with the University of Sydney and we built them sort of mini supercomputer, which we installed at the site. And this computer processes data from the sky roughly every millisecond.
Yep.
And we search for these mysterious things called fast radio bursts that are occurring in the heavens. These are flashes of radio emission. People don't actually know what causes them yet, although we suspect it's got something to do with either a neutron star or a black hole, because the burst is so short in time. And these flashes seem to occur many thousand times a day. But radio telescopes only look at such a small part of the sky that there's only about 50 that have been found. So Molonglo has an advantage in that it looks at a large amount of the sky and it's got a large collecting area.
Yep.
The receiver technology it's kind of cheap because it has to catch data from so many different parts of the telescope. So there's 352 independent receivers. So it's not sort of super sensitive, but it does look at a large amount of the sky.
Yep.
And it's found 5 fast radio bursts in the last couple of years, and the very latest one, we actually managed to dump the voltages that were being induced in the receiver at the time of the burst.
Yep.
Because we detected it within about a second of it occurring. And so we still had a copy of the raw voltages for the last 10 or 15 seconds in our computer's memory, and we wrote them out to disk, and that enabled us to study the system on microsecond timescales.
Wow.
Which has only ever been possible for one other fast radio burst. It's one called the repeater,
Yep.
which is quite a famous one. It's the only one that we know of that repeats. And this fast radio burst showed structure on timescales down to about 40 microseconds. So there's something either in the magnetosphere of the fast radio burst or near the black hole or whatever it is that's forming them that is only something like 40 microseconds in time across. So if you multiply that by the speed of light, you can get the idea that we're talking scales of only a kilometre or few.
Yep.
That are causing these systems.
Look, while we're on fast radio bursts, what is it that convinced you that they're the real thing?
Yeah, so as you said in your introduction, I worked with Duncan Lorimer and his team in publishing the first one. I was at the Parkes telescope with Duncan, and he showed me some of the hints that they'd detected something interesting, and we were lucky enough to have some tools to be able to look at the data in a different way than Duncan could. And we're very surprised to see such a perfect, what we call sweep of the radio emission from the high frequencies down to the low frequencies.
Yep.
But the Lorimer burst was so incredibly bright that it almost seemed too good to be true. And if you have a very bright object, normally in nature, if you can detect one really bright star, there's usually sort of thousands of faint ones. In nature, very bright things seem to be rare, but you often have large numbers of fainter objects.
Yep.
And just the way that things are distributed in the universe, if the Lorimer burst was real, we should have been detecting fainter versions of it or analogues of it further away. And our initial attempts to do that all failed.
Yep.
So I was a little bit concerned about the reality of the Lorimer burst. And even more so when one of my students, Sarah Birks-Law, discovered that there was a source of man-made interference near the Parkes telescope, which also showed some of the same characteristics as the Lorimer burst. In the meantime, we'd commissioned a new set of receiver technology by working with our friends at Berkeley, which was sort of perfect for looking for fast radio bursts. And although I might have sort of doubted their reality, we were fortunate that a PhD student at the University of Manchester was searching the results of a new survey that we've done in collaboration with international partners, and we actually found 4 fast radio bursts in the first pass at our new survey's data.
Yep.
And one of them was, again, very bright, but the improvements in technology really made us think that these things must be real. And then I think by the time the repeater came along, there was no doubt they were real.
Absolutely, yep. So one of your specialties now, Professor Bales, is using custom-built supercomputers to create models and simulations and to extract information from huge data sets. Now, this is the face of modern astronomy, and every day almost we're hearing of new instruments like the SKA precursors and FAST coming online that generate mountains of data so quickly that we barely have time to interrogate loops of that data. And we certainly don't appear to have the data warehouses and storage capacity to save it for later use. Now, I'm reminded of the importance of archival data with your work on the Lorimer burst. Do we simply run the risk of losing really valuable data because our algorithms can only find what they're looking for?
That's a second of data.
Yep.
And it's impossible to look at every byte by eye. I don't see it as a problem. I think it's just a new skill set that we're learning. But I am reminded that when we discovered the Lorimer burst, the data processing software that we used actually looked at the Lorimer burst and the fact that it was so bright and decided that it must be interference because nothing that bright should exist in the sky that we didn't already know about.
Yep.
So the Lorimer burst was lucky in that it was in a 13 beam receiver, and its arrival in the main beam of the telescope was so loud that our software decided it must be interference and actually deleted it. But we were lucky enough to pick it up in two of the what we call side lobes, which just got a faint echo of the Lorimer burst, but it was so bright that it was actually a reasonable signal. So I've no doubt that similar things are probably happening today, that we're probably deleting things that are actually interesting, but nobody can complain at the rate of scientific progress, with these new tools. I think that in time we're not going to let too much slip through the net, but we're at a transition between looking at your data by eye and looking at it with computers, and it's just part of the evolution of science, I think.
It is indeed very exciting times. Thanks, Matthew. So what an amazing and wonderful journey. Do you want to tell us about some of the other collaborations you're working on at the moment?
Certainly. So the South Africans have just built a new telescope. It's an official SKA Pathfinder. It's called the Meerkat.
Yep.
It's 64 dishes in the Karoo Desert in the north of South Africa. And it's beautifully engineered. And they have almost all of the 64 dishes working. And I'm part of a collaboration that stretches from South Africa to Australia, over to Europe and the US and Canada. And we're bringing together some of the world's best, what we call pulsar timers, to use this telescope to look at radio pulsars.
Yep.
Now, like most sort of good new bits of technology, it's quite a bit more sensitive than existing telescopes in the Southern Hemisphere. And we think we'll be able to look at over 1,000 pulsars a day using this instrument and study gravity in ways that haven't been possible in the Southern Hemisphere to date. So that's an exciting project. We should get our first tranche of official time in the next month or two, and we're just putting together the necessary sort of data processing pipelines and tests to check that system's working the way it should.
Fantastic. Okay. Now, the microphone is all yours now, Matthew, and you have the opportunity to give us your favourite rant or rave about the challenges that we face in science, in education, in equity, in outreach, our quest for knowledge and space, etc. It's all yours.
Okay, thanks, Brendan. Look, I think science is well funded globally. I don't think it's well planned globally. I'm very fortunate that I'm the director of a National Centre of Excellence, and we get 7 years of very generous funding, not only from the Australian Research Council, but also our host universities.
Yep.
And that really allows us to not only plan our science very well, but also to collaborate with people in a non-competitive way. Many scientists around the world have to try and get individual grants or grants in a very big pool, and that's a very competitive and sometimes destructive process. So I'm very fortunate that I don't have to spend a lot of my time applying for money. I know what I'm going to get for the next 7 years.
Yep.
So I think these large-scale investments are very good. They do require people to play nicely together, but I think it really puts the onus for success back on the scientists who attain these very large grants. I really feel sorry for people who early in their career fail to win research funding, because if you get grants early on, you get a bigger team, it's possible to be more productive. If you don't get grants, you often get given more teaching, and it can be a bit of a sort of vicious cycle where you don't produce as much, so next time you apply for a grant, you have even less chance, and you end up with sort of haves and have-not.
Yeah.
So I think enabling our scientists to plan is very important. But I also think scientists have an obligation to tell the public what they're doing with the money, and getting out into the schools and teaching children about the excitement of science, the value of science, and also when our PhD students come out the other end of their PhDs, I'm not a big fan of 100% of them trying to stay in science. I think it's very good for them to take those skills out into the workforce and use the techniques that you use and the discipline behind the scientific discovery and put that to use for industry to generate, if you like, jobs and growth.
Excellent. And yeah, we're calling this golden age of astrophysics at the moment, and what comes from it, there's something new and exciting every day. So thank you, Matthew. And right now we'll warmly invite our listeners to follow at Matthew Bales on Twitter and follow his fabulous journey of discovery. And thank you so much, Professor Matthew Bales.
My pleasure.
Oh yeah, okay. There's a switch on the mixer. I've got to remember to switch. Anyway, you're tuned to VK3 EKH ASV Radio, official station of the Astronomical Society of Victoria. My apologies for the audio on that. A number of the audio files on Astrophys website are a little bit rough with audio artifacts, and the problem with that recording was that Matthew was clearly off the microphone. He was probably using the internal mic in his laptop or something like that, and as a result it had horrible reverb in his office or wherever he was sitting to do that recording, and unfortunately there was a combination of reverb and a little bit of distortion because he wasn't quite on the microphone. That's the whole problem with digital recording. You've got to be on the microphone with the good level. If you intend to record audio digitally and you're off the microphone, there'll be more artifacts in the recording process, and it just sounds shocking. And I'm sorry about the quality of that, because once Brendan spoke, it was fairly clear, but his audio was a bit rough. I even through the headphones, I struggled to get a clear indication of what he was saying. So yeah, that's the source recording. I can't do much about that. I was actually fiddling with the EQ to try and get rid of that background reverb. Anyway, that's another story. But nevertheless, Professor Matthew Bales is that was, and he's a local lad. So all very good. All right, now I think the level on 80 metres needs to come up a little bit. It looks a little low. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's a bit better for 80. Sorry about that too. There's so much controls around here. Okay, it's coming up to 11 o'clock. What I'll do is there was just one thing I was going to indicate tonight, and it's okay, here it is. Watch Mars live stream from European Red. Watch Mars live stream from European Red Planet Orbiter today, and this will be the closest you can get to a live view from the Red Planet. First Mars live stream. Let me just refresh this page because the internet has been good tonight. So this was published about 3 hours ago, and the European Space Agency will live stream imagery from Mars Express Orbiter in near real time today, June 2, and you can watch it live. The event held to celebrate the 20th anniversary of Mars Express launch and will begin today at noon, 1600 hours GMT. Watch it live here at space.com, courtesy of the Europe Space Agency. And this will be the closest you can get to a live view from the red planet. The officials are saying Mars Express images will get to Earth today, 18 minutes after they are snapped, and if all goes to plan, they add it will take 17 minutes for them to get to our planet from Mars, then another minute or so to make it through the servers and wires on the ground, they say here. Mars Express launched with a lander called Beagle 2 on June 2, 2003. The duo arrived in orbit around the red planet on Christmas Day of that year. Beagle 2 touched down on Mars the same day but never phoned home, apparently because one or more of its four solar panels failed to deploy properly and ended up blocking the lander's communications antenna. Mars Express, however, got up and running as planned, studying the red planet in detail with 7 different science instruments. The orbiter has accomplished a great deal during its 2 decades away from Earth. For example, it detected methane in the Martian atmosphere, mapped the composition of ice near the planet's poles, and spotted a possible subsurface lake near Mars' south pole. And Mars Express is still going strong, as today's event shows. The live stream will showcase images snapped by the probe's visual monitoring camera, VMC, which was originally designed to monitor the separation of Beagle 2. Once it did that, the VMC was turned off, but it was turned back on in 2007 to snap imagery for education and outreach activities for science work as well. We developed a new form of sophisticated methods of operations and image processing to get better results from the camera, turning it into a Mars Express 8th science instrument. VMC team member George Barnell said in a statement, Mars Express team members have spent the last few months preparing for today's live stream. For instance, developing the tools needed to get the VMC photos online as soon as possible. Don't be surprised if there are a few hiccups, however. Nothing unusual about that. There is an old camera. This is an old camera originally planned for engineering purposes at a distance of almost 3 million kilometres from Earth. This hasn't been tried before, and to be honest, we're not 100% certain if it will work. But he says, I'm pretty optimistic. He added, normally we see images from Mars and we know that they are taken days before. So he says, I'm excited to see Mars as it is now, as close to a Martian now as we can possibly get. Anyway, so so look on the ESA. I think it'll be a YouTube on feed. So go to the European Space Agency's YouTube feed at some stage today, 1600 hours. I'm not too certain when that will be, but it'll be sometime Saturday. All right, so that's all I wanted to say on that one there. And spaceweather.com. Currently, the solar wind is at a speed of 384 kilometres a second. Density of 2.98 protons per cubic centimetre. The disk of the sun, which I can bring up, there it is. That's the current disk of the sun. And there's currently 1, 2, 3, 4, 5, 6, 7, 8, 9, possibly 10 sunspots on the disk of the sun as we speak. The current sunspot number is 143, with the radio sun measured at a wavelength of 10.7 centimetres, 164 solar flux units. That's quite high. 164 solar flux units at the moment. There is a minor geomagnetic storm watch. NOAA forecasters say that minor G1 class geomagnetic storms are possible late on June 2, when a stream of solar wind is expected to hit Earth's magnetic field. The gaseous material is flowing from a pair of holes in the sun's atmosphere. And interesting enough, they've got a little interesting image here, which is a mosaic of sorts. 31 days. What that picture represents on the screen right now is 31 days of 100 plus sunspot number. Solar Cycle 25 just hit another milestone. Every day last month, 31 days in a row, the sunspot number exceeded 100. Astronomer Senol Sani Bursa of Turkey used data from NASA's Solar Dynamics Observatory to display all of May's sunspots in a single image, and there it is on the screen. The last time this happened was in March 2014, when the sun also reeled off 31 consecutive days of 100 plus sunspot number. And that was near the maximum of the Solar Cycle 24. 9 years later, Solar Cycle 25 is just getting started, and it is shaping up to be much stronger than its predecessor. So there it is, all very exciting stuff. The current aurora over the South Pole is this one here. So there's a little bit of auroral activity, but nothing to write home about. So it's fairly average at the moment from what we can see on the current image there. Okay, so that's about it. Where's this other information that I usually give? The planetary K index. Currently, the KP is equal to 2, which is considered quiet. The 24-hour max KP figure was equal to 3.33, which is also considered quiet. Okay, and something else I was going to say, cosmic rays. The Solar Cycle 25 is intensifying, and this is reflected in the number of cosmic rays entering the Earth's atmosphere. Neutron counts from the University of Ulu-Sondankali Geophysical Observatory, that particular one, show that cosmic rays reach Earth are slowly declining as a result of the yin-yang relationship between the solar cycle and cosmic rays. Don't always mention that. Potentially hazardous asteroids. As of the 2nd of June 2023, there are 2,335 potentially hazardous asteroids. And if I had time, there was actually another interesting thing that's come to fruition. I didn't save the page, but there's apparently an asteroid that's following Earth. I'm not sure if it's in the same orbit or not. I'm not too certain. I didn't quickly read that. I just read that article very quickly, so I'll see if I can find that for next week. Okay, so I think that's about it for tonight. So I hope you found of some value tonight's session. Again, sorry for the audio quality of the Matthew Bales recording. Certainly the very first 5-minute recording, courtesy of 3RN, was far better audio quality. So there it is. Anyway, nevertheless, that's it for that. Okay, I think that's it. I also apologise for the audio level for last week too. I listened to the YouTube replay last week, and I found that I had the audio level far too high for YouTube. I've made sure that I've kept that out of the red on the YouTube tonight. So I'm hoping that the audio level on YouTube is a bit better to listen to. Yeah, there it is on that one too. It's always crucial, this balance between vision and audio, and it's always the audio that will let you down in most cases. And I think most of us ATVers are well aware of that. All right, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. Running since 1988, is concluding tonight. We shall do a quick callback on 80 metres on 3541 for any stations wishing to quickly check in. I acknowledge the stations that have come up on our email address. G'day Andrew and Stephen, Wayne and Don, and with your reports, thank you very much for that. All the stations that checked in on the Discord window, Martin, VK7JAH, Kim VK5FUSC there, just popped in. Richard VK3VRS, and Mike Local Lad VK3XL. Cassiopeia was there too, and and I think that's about all I can... Oh, Steve, VK3SPX, and I think that's about it from what I can see there. So not a bad little turnout there on our Discord chat window. I forgot to mention that there was a YouTube or a video feed on the British Amateur Television Club. I did check that before going to air, and it was working fine. Well, it is working fine with the audio too. So, but I can see that the YouTube stream has held in for the full hour and a bit, so I'm pretty pleased with that. Okay, this is VK3EKH. Now, I'm just going to run a little bit of a check here. And I think we should be able to feed a little bit of audio from 80 meters over the through vMix too. This is VK3EKH listening on 3541 kilohertz for any stations wishing to check in.
3 Delta X-ray. VK3 Alpha Delta X-ray. VK3SPX. VK3 November Foxtrot Portable 3.
Okay, now I've got Delta X-ray as the top station. There might have been another one at the beginning because I was just turning up the level so I could hear it in my headphones. So VK3 Delta X-ray, VK3 Alpha Delta X-ray, VK3 SPX, and VK3 NF. Is there any other stations wishing to check in?
VK7 Juliet Alpha Hotel.
Okay, got you, Martin. No worries. All right, to the top, VK3 Delta X-ray, VK3 EKH. Go, Greg.
Yeah, good on you, Clint, and great broadcast. Good evening to everyone there this evening, and quite interesting. And cycle 25 intensifying, mate. Very good. Looking forward to it, mate. Intensifying even more. Signals tonight are tremendous, mate. You're sitting up there at 20 over. In fact, I think you're peaking at about 30 over. So excellent conditions there on 80 metres tonight. Anyway, straight back to you, Clint, and thanks for running the net, mate. You do a great job there every week, and we all appreciate it. VK3 EKH for the net tonight. VK3 Delta X-ray. Greg in Warrnambool.
Yep, thanks, Greg. VK3 Delta X-ray, VK3 EKH returning. Thank you very much again for your comments there, and thanks for the signal report as well. So all very good, and we try to please. We aim to please. But yeah, apologies for that. The quality of the audio. Nevertheless, thanks, Greg. VK3 ADX, Merv, VK3 EKH.
Yeah, VK3 EKH, VK3 ADX. Yeah, thanks, Clint, for broadcast again. Into Ballarat to York. Good to see everybody on the line there, and thank you.
Yeah, I'm not sure if you put it back to me there, Merv. Yeah, signal just slowly faded. Yep, all right. VK3 ADX, VK3 EKH replying. No worries, Merv. Yeah, you came up, and initially you were quite good on the signal was not too bad, but you slowly sort of faded off the microphone. So I don't know if you put it back to me there or not. But look, thanks, Merv, for calling in and giving us a quick report. Steve, VK3 SPX, VK3 EKH.
VK3 EKH is VK3 SPX. Yeah, Merv said 73 at the end there, Clint. Anyway, yes, good broadcast. Enjoyed that. Interesting to hear from Professor Matthew Bales. That was pretty interesting, wasn't it? All about the fast radio burst in particular. You were talking about, you started off with your regular report on the planets and what have you. I had to laugh about Venus because I was listening to a report of the NASA conference or news conference they had on there when they reported their findings on UFOs, which they've been investigating formally for about a year. And the number of people who mistake Venus for a UFO is quite amazing. And I thought that was pretty funny. And I hope I wouldn't be one of those people that would assume that Venus was a flying saucer, but apparently it happens. Anyway, also, live view from Mars, that'd be good, wouldn't it? I just done a couple of computations, and it starts about 3 hours from now.
3 hours.
I just tuned to the ESA YouTube channel, and it says the live stream starting in 2 hours. So, I'm not sure if I'm going to last 2 hours. We'll see about that. But that would indeed be interesting, wouldn't it? Okay, well, thanks very much, Clint. We'll see you again next week. VK3EKH, VK3SPX.
Good on you, Steve. I'm glad you worked out the timing there. My GMT clock here is once I lose power, it goes all funny, and I never get around to adjusting it. So anyway, you reckon about 3 hours? Look, there's quite possibly I'll be still up at that time. Knowing me, I'm a horrible night owl. So we'll see how that goes. But it should be interesting to see those. I mean, that was one of the whole reasons why I got onto the internet back at 1997. The Mars Pathfinder had landed on Mars, and at that time, of course, the internet was fairly slow stuff, dial-up modems, and I think the speeds that we were kind of looking at were 36k, and but still, seeing these images, these clean, high-quality digital images coming in from the Mars Pathfinder, literally as they were being received, that NASA was putting them straight to the internet. And I thought it was such an amazing thrill to see these images coming from this Mars Pathfinder in near real time, rather than wait till 6 o'clock news. So it made it all worthwhile getting onto the internet. And I think my provider was Aussie Mail at the time, and it all worked fine. We didn't know any better as far as speeds and download speeds and all that sort of stuff. It was all pretty good. Anyway, that's another story. Thanks, Steve. Okay, to another Steve up at the property, VK3NF, VK3EKH. G'day, mate.
G'day, please VK3EKH and the group VK343. That's 10 callers from ASV, where it's cloudy, overcast, and not going to sing outside, that's for sure. But a bit annoyed about that. All comments noted, and because the inquiry with the UFOs and all that stuff, now I watched a bit of that during the week. It's quite interesting how they're changed their wording of UFO. I can't remember what they call them now, but anyway, very interesting. I'll Clint, you should have asked if the frequency's in use. Tongue-in-cheek, it is that side up here. I've got JA sitting underneath, even right at the moment there's still about 5 and 7, so that's how good the band is, or how quiet it is up here. It's absolutely beautiful. I'm a T2000, brought up for a run this time, and going to muck around with a few antennas tomorrow. I've got a 106 metre loop to put up, but I might even go bigger than that. I've got heaps of wires, so there we go. I've also bought a drone, but I haven't got the little attachment for it yet. I was hoping it was going to arrive yesterday, but it didn't happen, so to swing things up in a tree. Anyway, good broadcast, Clint. I didn't listen on Tuesday night. I was actually had to work this week. It was terrible. So in bed early, but anyway, good broadcast tonight, mate, and keep up. VK3EKH and the group VK343.
Yeah, I was just trying to listen. VK3NF, Portable 3, VK3 EKH returning, VK3 CSJ on the microphone. I can't hear anyone. There's no JAs that I can hear. The frequency is pretty clear. So I suspect that it's because your noise level there is much lower than it is here. And you've got the advantage of being a little bit closer to Japan. But I suspect it's because your band noise is perhaps a little bit better than it is here. Just as I'll check what that level is.
Tony, take Clint.
Right, okay. Band noise is right on S9, just for information's sake. It's right on Signal 9 going by the Pro 3 meter. Tongue in cheek. All right, fair enough. Okay. There's a little bit of RF feedback on your signal too, by the way, Steve. Just a little bit of RF feedback as you modulate. I can hear that. But I can still perfectly hear what you're saying. Okay. Thanks, Steve. Good to hear you. Thank you for calling in the comments. Martin down at Tasmania, VK7JAH, VK3EKH. VK7JH, VK3EKH. Yeah, bit difficult copy, Martin. It's the usual sort of signal that I get from down that way. So yeah, a little bit tricky. If you go back to this YouTube recording, as soon as I stop streaming, which will be in a moment, go on to the YouTube. Well, you did mention something about watching the YouTube stream, so you're already there. But play back this moment. Same with you there, Steve, Mr. NF. Go and look at the YouTube stream, and you'll hear your feedback happening or whatever was going on. But yeah, so it's all being recorded and direct to the system. So you'll be able to hear how strong you are up here tonight there, Martin. Anyway, all right, thanks guys. I appreciate the check-ins, all very good stuff. Now, is there any other stations, VK3EKH?
JR.
Go ahead, Frank.
G'day, Clint. Great broadcast. I missed half of it, first half, due to going to the AGM of the EMDRC, which was very good. Quite a big attendance, relatively so. Enjoyed Professor Bales. I heard the second half of him. And, of course, space weather is always essential listening. Had good news tonight with the sunspot prediction. No missions tonight. So if you have a late night, you'll have to find something else to listen to. Thanks a lot for doing it, Clint. It's always good. Maybe catch up with you on 160 metres, perhaps on a Saturday morning, maybe tomorrow, if you're on. Thanks for doing it, and talk soon. VK3EKH, VK3JR.
Good on you, Frank. VK3JR, VK3EKH. Very good, excellent. Yes, I'll be on the Coffee Net tomorrow morning, probably from about, at least from 11 o'clock, but I know that Gus, VK3AGP, usually kicks it off about 15 minutes earlier. Steve 3HK will probably roll up as well. They probably one or two. Even Steve might roll up too, Mr. SL. He usually pops in for about half an hour before getting called away. So yeah, we'll be up there on the Saturday morning net for a little while at least. Not a problem. All right. I just might mention too, in respect to all that. This is I think this is the fourth week now. It's amazing how quick a month has gone by. Yeah, I think this is the fourth week now that I do. I'm now doing the WI broadcast on 160 meters AM on Sunday morning. So it's 9 o'clock. So it's half an hour before the REC broadcast. I'm still trying to work out whether 9 o'clock's a good time or not. But it's been years since the WI broadcast presented itself on 160 AM. So I've decided to utilise the system here to run that at 9 o'clock on 1825 is the frequency. 1825, that's just because that's where the antennas work. And that's where everybody else is on 160 AM. Excuse me. So I'm doing the broadcast on Sunday mornings, 9 o'clock, 1825. Would be nice to get some reports through. And then, of course, at 10:30 I do the broadcast again on the ATV repeater, followed by the OTC broadcast, the Amateur Old-Timers Club. It's this weekend is the news bulletin, so I'll probably run that. Usually I do run that straight after the news, so it's 1 hour of news on the TV repeater, and I might even do that on 160 as well. I might I'll think about that, but I'll run 160 and then I'll do possibly straight into the news bulletin maybe, but I'll definitely do it on the repeater, which will go on the YouTube stream as well. For what it's worth. All right, so this is VK3 Echo Kilo Hotel, concluding for tonight on the 2nd of June, a new month. And thank you for watching and listening, everyone. And we'll be back next Wednesday, next Friday. I'm tired to do it all again. And I'll have a bunch of articles to read. I'll give the podcasts a bit of a rest. So this is VK3 EKH. Thanks everybody for watching and listening. Everybody on there on the chat window, and we'll see you all next week. Take care. Have a nice weekend and stay warm. This is VK3 EKH listening clear on 83541. Okay. No stations coming up on the frequencies. Everybody's falling asleep. There is somebody faint in the background there. Somebody very, very faint. Maybe that's those Japanese stations. All right, this is VK3 EKH ASV Radio concluding for tonight. Thank you for watching, and again, we'll be back next Friday with the stream. I'm glad the YouTube stream hung in there, which is really good. So thank you for watching, and cheers to you there, Mike, if you're watching the stream and as well. So we shall go to Calabaras. I think that's all I've got to do. I don't think there's anything else for me to carry on about. That's it. Cheers, everyone. Bye.